Hello, this is Mr. Stansbury. I'm going to take you through the notes on using technology to find binomial probabilities. At the end of this, you should be able to say, I can use a graphing calculator to solve more difficult binomial probability problems. All right, so let's jump straight into it and look at a question here. We got Beatrice the bunny has a 90% chance of making it through her entire course of the Bunny Equestrian Championships without knocking down a bar. If Beatrice runs through the course 7 times, determine her chances of, and we're going to do all these different things here. First thing, making it through 5 times without knocking down a bar. Now, this will be significantly easier with technology, hence the using technology piece. So I found something that I think will help you out. So this is the binomial distribution using a TI 83 and 84. Okay, so I know this looks kind of weird right now, but I'm going to go through and explain this, and it should help you out significantly on this. So N on here is the number of trials, P is the probability of success, X is the number of successes. So if we're looking at A, if we want to fill in these 3 things here, number of trials on all of these are going to be 7. Probability of success is going to be 0.9 because it's 90% chance. And then number of successes really on all of these are going to be 5. So I actually went through and made this to fit this problem so that this will hopefully make pretty good sense. So first one says making it through 5 times without knocking down a bar. So that we would assume would have to be exactly 5 times. So if you look at this first one here, calculate the binomial probability for exactly 1, or in our example here, exactly 5. So basically there's 7 chances. What's the probability that they'll get exactly 5 times through? Beatrice will get 5 times through without knocking down a bar. So when we're looking at that, we want to use the binomial PDF. Okay? Now, to find the binomial PDF on our calculator, our TI-84 here, we're going to do second variables, because if you look up above that, that's distribution, and this is the binomial distribution. So we do that, and we are going to do the, let's see if we can find it here. Okay, we just got to arrow down, and here's the 2 that we're going to want to use throughout here is binomial PDF and binomial CDF. Okay, just so you know the difference between the 2, binomial PDF, that stands for binomial probability distribution function. That finds an exact value like just 5, just 6, just 7. And binomial CDF is binomial cumulative density function. So that's going to find up to 5 or up to 4 or something of that nature. So that's the cumulative, and that's probability, that's like a specific number. So on this one here, we are looking for exactly 5, so we want to push enter here, and then it asks us number of trials. Our trials here is 7. The P, the probability of success, is 0.9. Our X value, what we're looking for, that's the number of successes, that would be 5. And then what it's going to do is it's actually going to paste it into this formula here. Binomial PDF, again, 7 is the number of trials, 0.9 is the probability of success, and 5 is the number of successes. They're all separated by commas there. And if we push enter here, we should end up getting 0.124, meaning that there is a 12.4% chance that they will go through and get Beatrice will go through and hit and have successfully gotten through 5 of her 7 trials. Exactly 5. Not 4 or anything less, not 6 or anything more. Exactly 5. So that would be 0. Oops. Let's see. Let's do that up here. 0.1. What did we have? 0.124. Okay, so our chances or probability is usually best just to leave it as a decimal. Okay. Now for B, it says making it through at most 5 times without knocking down a bar. So that means what's the probability of getting through 1, 2, 3, 4, or 5 times? So that's at most 5. Okay, so when we do that, we want to go into second variable, so which is our distribution, and now we want to get down to our binomial CDF. That's our cumulative frequency, cumulative density, function. Okay, so we want to push enter there, and again the number of trials is 7. Our p-value, probability of success, is 0.9 or 0.9, whatever you like. The number of successes we're looking for here would be 5, and then it's going to paste it in. And now this is going to add up to what's the probability of getting 1, 2, 3, 4, or 5 successes. So this should be a higher probability here, and it is, but not by much. 0.1496, so we'll call that 0.15. Okay, so we got 0.149, so we'll call that 0.150, right? Because our 6 takes our 9 and turns into a 0, so go with that. All right. Now we got a few more to take a look at, but before we do that, let's take a quick little comedy break.
So much the number, man, it's I feel old. Some things happen to make me feel old. For example, I read an article not too long ago. Society says the average man at 27 should be married. It's very depressing. So I don't think society factors in things like maybe me and a wife at this point in my life can come together and fit in my mom's basement, because it's not that big. It's finished, but it's damp. Sure ain't gonna want to do it.
All right. Moving on here. C, making it through fewer than 5 times without knocking down the bar. So that would be fewer than 5. That would be 1, 2, 3, or 4. Okay, so really we're going to go back in here, and we're going to use this same thing here. Now I'm going to do this instead of going back through. Well, let's see what it gives us. Second distribution. Oops, too far. Push enter. Oh man, I messed that up. Okay, let's see. We got to get out of that. Let's try that again. Second distribution. And we're going to go down to, once you realize what number it is, you could probably type this in each time, but I'm fine just scrolling down. We have to go down to B. So, good news is it kept our old info. So 7 trials, probability is going to be 9 here, 90%. And our X value, we want to know up to 4. Okay, so we got to change that X value from 5 down to 4. We push paste, puts our info in there, and that tells us that it's a 0.0256. So it's that's like a 2.6% chance. So we're going to round that to 0.026. Okay, again, pretty small. Pretty low probability. If you'll notice here, we're matching up with what we're supposed to get, so that's good. Okay. Now, making it through more than 5 times without knocking down a bar. So if we're going to go through more than 5 times, that's going to be either 6 or 7. So really what we want to do is we want to take, basically that's going to be the complement of at most 5. Most 5 is 1, 2, 3, 4, 5. More than 5 is the rest, 6 and 7, right? So what we'd really want to do with this here is we want to find the complement of this at most 5 right here. So we could put it into our calculator here, but really it's just saying 1 minus this at most 5, and we already know that that's 0.150. So what we can do is just do good old math here, and we're going to do 1 minus our at most 5, which is 0.15, which is going to give us 0.85. Meaning there's an 85% chance that they're going to make it through more than 5 times without knocking down a bar. because again, the probability is so high. Okay, so again, you want to think complement on this. That's up through 5, and then we left off the 6 and 7, so that 6 and 7 is what we're looking for. So we know that all 7 of these together should add up to 100% probability. So that's what we're doing, our little complement there. Okay, and then same thing on E. So that was our work for D. The same thing for E. What's the probability that they make it through at least 5 times without knocking down a bar? So that's 5, 6, or 7, which would be the complement of this one here, because that's only 1 through 4. We want to figure out 5, 6, and 7. So we'd take the complement of this one here. So, and we figured out that one earlier was 0.026. So we're going to do 1 minus 0.026, which is going to give us 0.974. Okay, and just really quick, I'll show you what that looks like on the calculator, so that at least makes a little bit of sense. So again, we're thinking complement here. So at least 5, because what the calculator is doing, it's always counting, adding up from starting with 1. So it's going 1, 2, 3, 4, 5. So we don't want 1, 2, 3, 4, 5. We want just 6 and 7. So we're going to take the, well, on this one, sorry, the one we're doing, we want 5, 6, and 7. So we want everything except for the 1, 2, 3, 4. So we're going to do 1 minus, and then that's where we do second distribution. And we'll go down to, what was it, B, I think? Binomial CDF. And this is where we have 7 trials, 0.9, 90%. And we want to know, we want everything except for the first 4, which is what we already have here. So we go down there, go into paste, and we push enter. And it should be 1 minus binomial CDF there. And it's going to be 1 minus that 0.0256, which gives us our 0.974, which is what we got here. Okay? Hopefully that makes some sense. If you need any further help at all with this or any other questions, please feel free to ask in class. Thanks.